Hello, my name is Ed Sanders. I'm the lead developer on Visual Editor, and today I'm going to talk to you about the Wikitext mode we've added to Visual Editor, which is currently available as a beta feature. And then my colleague Charlie is going to talk to you about the visual diffs. So the first topic is why we've added this Wikitext mode to Visual Editor. And the main reason is the improved tools we have in Visual Editor. We have lots of improved versions of existing tools, and we have a lot of new tools. And if you have better tools, you're going to be able to edit quicker, make fewer mistakes, and have sort of less fatigue. So we hope this will improve the editing experience for Wikitext users in the same way we did for visual editors. So I'll start off by giving a few examples. So here we have the link inspector. There is actually one in the Wikitext editor. This is the 2010 Wikitext editor, which most of you are probably using. There are even older versions, which you probably don't use anymore. It's very basic, and it was written, as it suggests, 7 years ago. So I won't hate on it, especially as the authors are both in this room.
It was a different time, man.
It's a different time. They went on to write Visual Editor, so they knew what they were doing. We have page images from the page image extension, Wikidata descriptions. It's all sort of inline over the link, and you can see exactly what you may get the autocomplete suggestions with nice previews. We have a great image tool as well. So before you just have to sort of remember the file name and then type a caption and fiddle with these drop downs. Now we have a nice search feature, and then I haven't got a screenshot, but on the next page there's a nice interface for editing the captions and
the alt text.
And the alt text, yes. But I think the real killer feature in Visual Editor are the citations. So there's actually a couple of features that have tried to address this in Wikitext. This is the basic one that you get for free. Just inserts a ref tag, fairly useless. We have Prove It, which lets you reuse stuff, which is quite cool. And this one, it's a gadget, I can't remember its name, and it lets you fill out the template forms, which are specific to Wiki. In VE, we have all of those features and more. And the and more part is the cited feature, which is really great. You just paste the URL and you click twice, and it generates a citation for you. We also have the reusing features and stuff. I showed you before. Other little tools like an improved find and replace with regular expressions, diacritic matching, word matching, highlighting. Keyboard shortcuts to trigger it. But really I think this is a great feature to have no matter what type of editing you're doing. And a lot of people have called for it in Wikitext Editor, so that's one of the reasons we're trying to unify these experiences. We want to deduplicate some of the code that we have lying around. So some of the features are pretty similar in both, but it's just we've got to maintain two versions. Maybe one point in the future, if we're all using one editor, that won't be a problem. There's also some places where the old editor just doesn't do the job and can't do the job because the technology didn't exist at the time, or it was just architected in a way that. So undo, for example, it relies on the browser undo. Which, if you actually use a tool from the toolbar, doesn't get inserted into the history stack. So you use the toolbar to make it bold, and you're like, oh no, I meant italic, so you press undo, and then it undoes the thing that you did before that. Depending on which browser you're using, Firefox I think works a bit better now, Chrome used to work not at all, Chrome now skips past the thing, it's a bit of a mess, and you end up flipping tables. Another thing that it doesn't have is any sort of keyboard shortcuts. So really the point of tools in the Wikitext editor is to make your life easier. If I'm typing and I want to make something bold and I have to take my hands off the keyboard, go and click the B thing, I might as well have just typed 3 apostrophes. Whereas if I can select the word and press Control B, I might actually think about using that tool. Mode switching. How are we doing for time? Oh, we're doing great. A lot of times, I don't know if many people in the room have experienced this, but you're in Visual Editor because that's your default, and then you just realize there's something you need to switch to Wikitext for, and then it reloads the page and it dumps you in a completely different editor. So for power users, that's annoying because it's slow, and for new users, it's super confusing because they've now been dumped in a new editor with completely different tools. And they're like, oh, how do I get back? And, oh, well, this tool, we've tried to make it in roughly the same place, but all of the other tools are just all over the shop. And also, it has to reload the whole page, reparse all the JavaScript, reparse all the CSS. if we use the same editor, we can just do an API call for the wiki text, and just that'll take less than a second probably. So yeah, this is what the new interface looks like with wiki text inside Visual Editor. We've also got the syntax Arlington beta feature on, but I don't want to steal someone else's thunder. That's coming up later. Stay in this room. So, those are all the great reasons why we wanted to do this. What about how we did it?
Why it took 10 years.
Yes. Well, we had to build the Visual Editor first. So you can blame someone else for that.
Sorry.
You're welcome.
Yes, so this is going to get a little bit more technical. So basically, I sort of took this on last summer and sort of came up with two basic approaches. Either we could take all of the V toolbars and widgets and everything and dump them on the old editor and basically do a refresh of the toolbar, which has some benefits. It's sort of a little bit less disruptive, but there's a whole bunch more work to do. We need to reinterface all of the toolbars and the tools with the wiki text, with the text area. We still have to reload the page, which is slower. And we'd have to, just to position everything, we'd have to rewrite a whole bunch of CSS and keep it maintained in two places, because we've basically got two editors now that just kind of look similar. The plan I went with, which is basically just to dump wiki text into the Visual Editor and say, well, this is just, it's like a rich text document, but it has no formatting in it. This has a whole bunch of benefits. There's a lot quicker to get going. It reuses all the code. We get all the UI stuff in CSS for free, and all of the tools are already there and hooked up to the surface. And using a few clever tricks, we can get them all working for free without having to adapt them, and then sort of later on adapt them if required. This is how we kind of started off with Visual Editor, which is we basically said, if there's a feature we don't support yet, like images, the early alphas of Visual Editor didn't support images, we'll just say, that's on the page, we'll leave it, we won't touch it. So the similar thing here with the tools. We're going to try and migrate everything in a basic way and then bring in the tools as we write more code for them, which is useful when you only have one person working on it. So how we brought all that together and made it work, we already had some useful abstraction in the Visual Editor, which is that the editing tools would go through this thing called the surface fragment before it started modifying our internal data model. So all of the document is stored in this data model, the current state of your document, and when you hit a tool on the toolbar, it tells the surface fragment to do something to the document. And this is great, and this dotted line here is the thing that it never writes directly to the model. And this is great because we can just intercept this. We can take all these actions which are visual actions. So for example, when you hit the B button, because Visual Editor is an HTML editor, it actually adds a bold annotation to each character. Or if you say insert image, it will insert, if you say insert heading, it will insert heading tags around it. What we can do is we can then insert that content into a hidden rich text document that you never see, take the contents of that document, round trip that to Wikitext, which is something we already do when you hit save in Visual Editor, and then put that response back into the plain text document. And this gives us basically all of the basic tools just with one bit of code. So we upstreamed all this into the core Visual Editor, which is the HTML editor, and made it work so that it inserts rich text into the hidden document and then just converts it to HTML. So now you have, if you install the core Visual Editor, which is a standalone for MediaWiki, that now has an HTML editing mode. And then we just override one method in the Wikitext version, which instead of converting to HTML, has an API call to parseoid and convert it to Wikitext. So like, there's a bit more than this, but this is essentially all that we needed to add to make this, instead of being an HTML editor, a Wikitext editor. Like I said, it's still a beta feature. There's a lot more to do. There's a few things on the horizon. We have to look at making it a bit faster, especially on long pages, and also the sort of time to first load. At the moment, we're still loading probably a lot of Visual Editor code that's not required, so we could probably separate our modules a bit better and get the time to first load down a bit. When I say APIs here, I'm talking about sort of gadget writers, people interfacing with the surface. So if you're like, give me the 100th character, because we wrap every line in a paragraph, we have to do some sort of offset. So we need some slightly better APIs for gadget writers, so gadgets can be easier to migrate. We'd also like to get feedback from people using it on the sort of tools that they already have, or tools that are specifically to Wikitext. Like for example, inserting no wiki tags has no visual analogy because that's only a syntax escaping feature. Like I said before, all of our tools work out of the box by round tripping. In some cases, that's probably a bit heavy-handed because you could probably just build the wiki text in the client. We haven't done that for most of the tools. I think we've done that for headings because it's such a simple piece of syntax to reproduce, just to insert the double equals. But even for links, there are edge cases where it's probably just easier just to round trip it because Parser has done such a great job of creating valid wiki text. So. And the last one is the really big one, which is at the moment most of the tools are insertion tools and not editing tools. So if you place your cursor in a link, it doesn't edit the link yet. I think you can select the text and edit it that way. But it's not sort of context aware the same way the visual editor is. Visual editor is constantly aware that if you put your cursor here, you are within a link, within a paragraph, within a table cell type thing. That's not true in wiki text. It's harder to work it out because the wiki text isn't necessarily even balanced at that point in time. You might have two left brackets and not a right bracket. So we need to sort of look at that on a case-by-case basis, but it'd be great if you can place your cursor in some wiki text and it'll say, oh, you're in a link, would you like to edit it? We do it for headings and stuff already. A lot more to do on that, extensions and stuff like that. And that's it. Now you get to see something even more exciting, which is Talia and the visual diffs.
So yeah, I'm Talia and I've been working with the visual editor team on visual diffs. So I'll give you an introduction to what they are, why they're good, why they were difficult, why we did what we did, and hopefully it'll help you sort of understand why they behave how they do. So first of all, when I say visual diff, that's not to be confused with Parsoid's pixel by pixel diff of the page rendering. And for anyone who wanted to hear about that, I'm very sorry. That's not this talk. But you are probably familiar with wiki text diffs, like we have here. And they highlight the changes between two revisions of the same document. And until recently, this was the only diff that was available. So even if you're a visual editor user who doesn't understand wiki text, this is the only way you can see the difference, the edits you've just made. So.
What about Wikid's diff?
Wikid's diff?
Yeah.
I would love to hear more about that. But when you're using visual editor and you get to the review changes dialogue, the only thing you could see at that point was the wiki text.
It's still what you see by default. You then have to click another button to get visual diff.
Yeah, that is true at the moment.
Is that a little strange?
It would be wonderful to have the visual diff as the default in the future.
It's
Yeah.
still in
Visual
beta. It's still in
editor.
beta.
In visual editor,
Around
of course.
beta.
Yeah, that's true. So this is how a visual diff looks. As you can see, it's showing you the difference between how the document looks rather than the syntax behind it. It's also unified rather than side by side. So as we discussed, you use diffs to see what you've just changed, but you can also see them to look at historical revisions to say, look for vandalism or check that a change is correct and so on. So why are visual diffs so complicated? Well, the first problem is how to display certain diffs. So wiki text is just a string of characters, and the diff just shows you the removed characters and the inserted characters. That's quite straightforward. This example, a bullet list has been changed to a numbered list, and it's not immediately obvious how you would even show that visually. Do you want to see crossed out bullets? Difficult to know. Here's a link. We've added a link. Again, this is a sort of behind the scenes change, so how would we show that visually? And then, in other times, the wiki text itself can be a little bit awkward, such as when you're editing a table. The diff can be awkward too. Here we've removed a column, which won't immediately be obvious to someone who doesn't understand wiki text very well. And here we might imagine how this diff would be displayed. We'd see a table with a column removed. But this time it's actually computing the diff, which is difficult. And the problem is the visual editor data model is a tree, much like HTML is a tree. And the reason why that makes diffing difficult is something which I'll talk about using examples. Okay, so here's a straightforward case. We've inserted a paragraph and we can easily stick insert tags around that to show the diff. In this example, all we've done is added a bold tag, and already it's not straightforward. We can't just stick insert tags around what we've inserted because that's not valid HTML. We can come up with some solution, such as showing the old formatting is removed and the new formatting is inserted. Actually, this is what we do in this particular case. But it can get even more complicated. In this example, we've merged two paragraphs, and again, we've got invalid HTML here. And it's not immediately obvious what the fix is this time, because it would be a shame to show all the old content is removed and all the new content is inserted, because that sort of defeats the point of the diff. So these are relatively simple examples, and we can see it's already getting complicated, and basically visual diffs are not simple. So next I'll talk you through some of the approaches that we considered taking. First of all, we had to decide, do we diff the HTML or do we diff the visual editor data model? And the idea of a generic HTML differ sounds great, but HTML can overcomplicate the document. So that would be a bit difficult to do. Visual editor has some advantages, such as a built-in distinction between nodes that contain content and nodes that are just structural. For complex trees like block images, we just have a single node there. And basically, the visual editor data model is a better semantic description of the document. The disadvantage of doing it this way is that if we're diffing historical revisions, we have to convert them to a visual editor document first, but that's okay, and that's what we do. Then we have a choice of algorithmic approach. Do we do what we've just seen in the examples, do some kind of linear diff and then parse that into a balanced tree? Well, if we do, then we have to write this whole parsing step, which can get quite complicated. Another thing that was suggested, and I think which is done in Microsoft Word's track changes, was using the user's transaction history, so that the changes they've actually made, to zero in on their changes. One of the disadvantages of this is if you make a small change, like removing a few characters and then retyping them, that already comes up as a diff, which isn't what we want to see. And obviously for historical revisions, we don't store the transaction, so it just wouldn't be possible to do it this way. So what we do instead is we diff the document as a tree, which just kind of makes sense because the document is a tree. So I'll now get a little bit technical, go into a bit more detail about how the tree diffing works, how we had to implement some time-saving steps, and then we'll see examples of the problematic diffs that we talked about earlier. So here's that paragraph merge again, expressed as trees this time. And now the problem is, how do we compute the difference between those two trees? So here are the trees, and they're color-coded, so if the node is the same color, it's identical. Tree diffing has been studied in a few different fields, and there are various algorithms available, but typically what you're trying to do is get from the first tree to the second tree via some predefined available moves, such as removing a node, inserting a node, or changing a node to another node. So there's an infinite number of solutions. For example, we could just remove every node of the old tree and then insert every node of the new tree. But this won't result in a very useful diff. If you want a diff where you can spot vandalism, where you can see changes, you want a diff that takes the minimum number of moves possible. And we found an algorithm that does this. That's the paper and a link to our JavaScript implementation of it. And it basically works by comparing subtrees and finding the minimal diff. So in this case, removing two nodes and then changing one node to another is the best we're going to get. So this is vaguely how the diff is going to look. We have the document, we know we've changed the first paragraph and we've removed the second paragraph. So we can put delete tags around the remove paragraph, and then the only step to do now is find out how that changed paragraph has changed, and we can do that using a linear diff, as in the examples from earlier. And basically it all ends up looking like this. So that was a relatively simple example, but our next problem now is that tree diffing a whole document like that is prohibitively slow if the document is sort of medium or large size. And documents do tend to be a lot bigger than the example that we just saw. So then we need to employ some time-saving heuristics, but also be careful that we still get the optimal diff. So we can use what we know about typical visual editor documents to do this. They tend to be quite flat, so what happens is we have this document node at the top, and then subtrees hanging off it, which can be paragraphs, headers, block images, tables, lists, and so on. And usually with most revisions, most of these subtrees are left completely unchanged. And it's very quick to check if some subtrees are identical, and we just change them into strings and compare that, and that's a very quick step. So we do a first pass where we remove the identical nodes. So now we have a much more simple amount of stuff to diff. Once we've removed the identical subtrees, we diff the remaining subtrees against each other and find pairs that are similar. And one freebie that we get out of doing it that way is we can see when a paragraph or a list or whatever has moved, because we know how the new ones corresponded to the old ones. And a sort of problematic sort of cases of vandalism with Wikitext diffs is you can change a paragraph and then move it, and it's not immediately clear what that change is. Whereas in the visual diff, it shows up like this. So you can see that it's moved and the change is highlighted. I should say, I think the people who write the Wikitext diff are currently working on that very problem. Okay, so we keep matching subtrees to each other, and then another thing we get for free is what has been removed from the old document or inserted into the new document, because anything left unpaired in the old document has obviously been removed. And so quite often we get to find this without even ever having to run a diff on this content. So that saves us a lot of time as well. Okay, so we're getting to the end of the technical bit there. In some edge cases, like large lists or large tables, the true diff might take a very long time. The linear diff can also take a long time. And so we add time limits to make sure that we don't just time out. In these cases, you may not get the minimal diff. The Wikitext diff might be better for those cases. So that's how we do the diffs. So let's see how we solve these problems. So again, this was the list that changed from a bullet list to a numbered list. And in this case, we went for a text description to show what has changed. These will get translated as well to different languages. The link example, we show that like a formatting change. But one nice thing about this is because we're in a read-like environment, we can still make use of features that exist in that environment, such as hovercards here. And then again, that table diff that was quite difficult to read ends up looking like this, which I think is a bit more straightforward. There are a number of things that we're still working on. In particular, we're designing quite a few things better, how to show move paragraphs, changes to things that you don't normally see in read mode, such as a comment node. It's not immediately clear how such a change should show up in a visual diff. Secondly, the generic tree diffing approach worked really well because it just meant we implemented all of this once and it worked for everything. So the first time we saw a table diff, the first time we tried it out, it just worked. We didn't do anything special. But then the problem with seeing everything as trees is humans don't really see everything as trees. So in strange cases with tables, such as if you merge table cells together, the diff you see doesn't quite make sense as a human, although when you think about it really hard, it turns out that it is a correct tree diff, but that's again not very useful to a user. So in some cases like this, there might be a way of diffing tables as if they are sort of 2D structures. And then obviously there are things that don't work very well in Visual Editor in general, and obviously these don't work in the diff either. So in summary, the visual diff complements the Wikitext diff. In different situations, one or the other may be more useful. And in general, the problem of diffing is quite a delicate balance between perfection and speed. But I hope this gave you some understanding of why the visual diff behaves as it does. If you haven't seen it, please check it out. And we'd be very grateful to hear feedback on both of these new features. And yeah, that's the end.
We have limited time left, I think, but we can take some questions before the next session. I'm sure they won't mind taking a little bit of that time. So, for all of us.
So why red and green?
Hang on.
Why red and green?
There was a very big discussion about this. I wonder if it's how specific to answer this question.
It's called the, yeah, building on intuitive meanings of how to represent removal and creation. Those are intuitive choices. They have challenges in terms of which specific shades you pick and whether to use only color to signal the removal for accessibility aspects. But yeah, in terms of information being removed, I guess the red was an accurate choice.
I think what you're also saying is why not blue and yellow?
Yeah.
Yeah, I think if it was a side-by-side diff, then probably blue and yellow would be fine. But because we're doing a unified diff, I think we need colours that implicitly say this is the stuff that's removed. Like if you're a visual user and you've not seen the blue-yellow diff before, you wouldn't know which of those colours meant remove and which one means it's
We deliberately struck out the removed text as well, so for people who struggle to see the difference between red and green, that people also got the strikeout to help indicate the yellow.
Just that red and green color blindness is the most prevalent one,
Yeah.
so those two colors are problematic.
Yeah.
We also have semantic tags in there for people with screen readers and underline strike throughs for readers as well. At the back?
Are there plans to have a side-by-side version of this? I think that might be useful for cases such as the bulletless turns and underlists.
Yeah, originally we did think about that, so yeah, there's no reason why that couldn't be something that we worked on.
Or it could be some moving diffs, so when you see how the changes evolve from the top to the bottom, for example, you see there pops something up that was changed on the next lines and such. Also an idea.
Yeah, and we've talked too about interactivity and being able to maybe hide the remove stuff. And, yeah, that's more.
Are you asking about like playback?
Multiple changes? Or just as you scroll?
Like the transaction history of like the person editing the document live?
I meant like when you scroll, for example, but also when you or done by yourself, or also like in a play mode that you can see.
We
all
do have
first
the
lines, second
individual
lines.
transactions of visual editor, but not for historical diff. So we've designed it so that we play. Quickly, one more.
So one edge case that bothers me in particular, in the wiki text diff, I don't know what the visual diff does. When you have like two paragraphs and you move them around, but it looks like you're just rewriting the paragraph, like 85% of it, when that's not actually what's happening. Do you have a good insight on how to approach that in either the wiki text or visual diffs?
Yeah, just anecdotally, I've seen cases where the wiki text gets fooled by that, but the visual diff still picks it up. When we decide whether two paragraphs correspond to each other, we have a threshold. If enough content is the same, then we say they do correspond. And it seems that that threshold is high enough. Yeah. The threshold seems to be high enough to catch a lot of those cases. It's about 50% or something. So 50% of the content would have to be the same for it to match up two different paragraphs.
And really quickly, one more.
Yeah, just a comment. You had that bullet that said everything is a tree, but not everything is best viewed as a tree, or something like that. I thought that was amazing. That's, I think every time we're thinking about data structures, we should remember that.
Thank you for not asking questions about the wiki text editing. Made my life easier. And stick around for the next session, which is what we do.